These are the 7.4 notes for Algebra 2. Today we're going to be talking about multiplying and dividing rational expressions. So this builds on what we've done before. The first thing we're going to do is factor each of these four problems. So I'm going to start with this top one right here and factor that. This is one of the factoring trinomial problems, so I'm looking for numbers that multiply to 8 and add up to 6. That pair is going to be 4 times 2, both positive. Then I'm going to move on to this denominator here, and again factor it. This problem is a difference of squares, so I'm going to need a square root. Square root of 4 is 2. And for these difference of squares problems, I always have one plus and one minus sign. Then I'll move on to the second half of the problem. I'm going to do the very same type of thing. So I'm going to take this one right here. This is a greatest common factor problem. So I kind of like to do those off to the side. I'm finding my greatest common factor. I'm looking for the largest number that can be divided by both, which is 5. And then the smaller of the two exponents, x to the third or x squared, that would be x squared. So I'm going to take 5x squared out of each of them. I'll go ahead and write my answer down here. So whatever is left when I divide will go in the parentheses. 5 divided by 5 cancels. X to the third divided by x squared. I subtract the exponents, leaving me an x, or x to the 1. 10 divided by 5 is 2. And the x squares are both going to cancel out. The very last thing, I'm going to do this one right here. That's again going to be another greatest common factor problem. So x squared plus 3x. My greatest common factor, all I'm able to take out here is an x. So I'll bring the x down. And whatever's left when I divide will go inside the parentheses. X squared divided by x leaves me x. Plus, and the two x's cancel there, leaving me 3. Now what I have when I'm multiplying, it's really like I have one big problem, so I'm just going to kind of connect these like that. And anything across the top can cancel with its exact pair on the bottom. So it's going to look like this. X minus 2 can cancel with x minus 2. X plus 2 can cancel with x plus 2. And this 5x squared, this x squared right here, I'm going to write instead as x times x. And I'm going to cancel one of the x's with that x down there. So in the top, I have a 5. I have this x left over. And I have an x plus 4. And in the denominator, I have an x plus 3. And there's my final answer. Okay, for the next problem, example number 2, we're going to do the same thing. We're going to start with this x plus 3. That one, because it's not an x squared and I don't see they have numbers in common, there's actually nothing I can do there to simplify that, so I'll just leave it. The next part, 4x plus 20, is going to be a greatest common factor problem. My greatest common factor is going to be 4, so I'll divide by 4, put the 4 in front, divide it out. 4 divided by 4 cancels, leaving x. 20 divided by 4 is 5. I'll move on to the next part. X squared minus 25, that's a difference of squares problem, so I'll square root that. Leaving me x plus 5 and x minus 5, always one of each sign. And the last part here is a trinomial. So I'm looking for numbers that multiply to negative 15 and add to negative 2. 1 times 15 and 3 times 5 are the only pairs I can think of, so I'm going to use the pair 3 and 5. And just make sure the signs are correct. This would have to be a positive 3 and a negative 5 in order to add up to negative 2. And then let's see what cancels. I have an x plus 5 to cancel with the x plus 5, x minus 5 with the x minus 5, and this x plus 3 can cancel with that x plus 3. As long as one is at the top and one is at the bottom, it can cancel across the entire multiplication problem. This leaves me just a 4 in the denominator. Because there's nothing at the top, I'll put a 1 and have a final answer of 1/4. Those two were multiplication. The next one we're going to do is division. Notice that we have a little bit of a change here. Anytime we're working with dividing fractions, you want to flip the second fraction and multiply. So we'll go ahead and do that as we write it. I'll start first just with the x squared. Not sure I can do anything with that right now, so I'll just leave it as x squared. This next part right here is a trinomial, so I'll put a little 1 there. I need numbers that multiply to negative 42 and add to negative 1. That should be a 6 and a 7. The 7 will have to be a negative, 6 is positive. You can always double check those in your calculator. All right, and then right here, because this is a division sign, we're going to make sure we change it to a multiplication. And then take this and flip it. So this x, which was at the top, is going to end up at the bottom. And this x squared minus 36, that difference of squares, is going to end up at the top. Square root that. X plus 6 and x minus 6. And because, again, this is now multiplication, we can go across the entire problem, canceling what matches. So I have an x plus 6 to cancel with x plus 6. And I have an x squared and an x. This x squared can be written instead as x times x, which then I'll cancel one of those with one of those. Let's see what's left. I've got just this x left, the top with the x minus 6, and at the bottom, x minus 7. All right, let's do one more division problem. Example number 4 on the back side. We'll start with this 8x plus 48. That's going to be a greatest common factor problem, so I'll do it off to the side here. The biggest number that can go into both would be 8. The 48 does not have an x to give up, so my greatest common factor does not have an x in it. I'll take the 8 out of both. And then I'll just figure out what's left. 8 divided by 8 cancels, leaving me x. 48 divided by 8 leaves 6. Now we'll shift our attention to the bottom one. That's a trinomial, looking for numbers that multiply to negative 54 and add to negative 3. If you're stuck on 54, you can always come off to the side and just start thinking of numbers that multiply. You can even get your calculator and start dividing. So 2 times 27. And just see what else goes into 54. 3 times 18. 6 times 9. I think that 6 times 9 is going to be my pair. It's going to be the thing that's going to be able to make 3. The 9 is going to be negative, 6 is going to be positive. Then because of this division, I'm going to flip this. I'll change that to a multiplication sign. This x minus 3, there's no greatest common factor there. So I don't have to do anything with that. I'll just move it to the bottom. And then x squared minus 6x minus 27, that's going to be just like the problem we just did over here in green. It's a trinomial. You're trying to find numbers that multiply to negative 27, add to negative 6. So again, if you get stuck, you can always go off to the side and make a little chart. Right? All the numbers, that'll work. And that one's got to be 9 and a 3. The 9 is going to be negative and the 3 is going to be positive. That's the only way they can add to negative 6. If you switch those signs around, they add up to make positive 6. Once everything is factored out and you're multiplying, you can have one big problem all the way across, and you're free to cancel anything that matches at the top with its pair at the bottom. So x plus 6 and x plus 6. X minus 9 and x minus 9. And then I notice these 3's. One is an x plus 3 and one is an x minus 3. Those do not cancel. They have to be the same sign in order to cancel. So I just have to leave them there. Across the top, the numerator, I have the 8 from way up here. And then I've got the x plus 3. And then the only thing left at the bottom in the denominator is the x minus 3. And unfortunately, those can't cancel, which just means that that's my final answer.